We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
1, 0, all engine running. Liftoff. We have a liftoff.
Houston, Tranquility Base here. The Eagle has landed.
Hello, thank you for joining me. I'm your host, Adam Tilted, and this is Orbit at a Tilt, the space and science show that is fun and easy to understand. I am coming to you live from my brand new studio. Check it out. Thank you to my husband, Scott, who spent the weekend setting this up for me. Let me move this out of the way so you can see the full effect. I have all this space. I'm so excited because that means I'm going to be able to do some fun science experiments live on camera. More about that later. Thanks for joining me. We've been looking at the space station before. We've looked at the resupply missions. And I've gone over a little bit about how some of the parts of the space station work. Whoops. But what goes on up there anyway? I mean, it's an amazing feat of engineering and technology, but do you know what happens on the space station? Well, after tonight, you will know a little bit more, at least, about what's going on up there. Now, I'm making a couple of adjustments. Because I'm in a new space, this is my first time broadcasting with this setup. So if there are any issues, I will need you to let me know. I'm just going to do a quick check in my browser to see if I can hear myself and make sure that that's all coming through okay. Sounds good. Okay, let me know if that changes. And let me get back to my screen. Great. Before we take a look at some of the science that goes on in the International Space Station, let's take a look at the night sky for this week. Here is the current sky looking to the southwest from Houston, Space City, USA. So this is what it looks like in my backyard right now. And I'll speed time up just a bit. So we can start to see what happens after the sun goes down. And we've got a beautiful view again of the planets. So let's go a little further. Let's get a little darker. And I can pull down a little bit. So see again, we've got, starting over here in the west, we have Venus, Jupiter, higher up, Saturn, and Mars. It's a beautiful sight. I got my telescope working. I'll tell you that story maybe tomorrow on What's Up Wednesday. But I got a glimpse of Saturn with my telescope, and it was breathtaking. So I encourage you, if you have a backyard telescope or even a decent pair of binoculars, go out and take a look, because the planets are definitely on parade. Okay, so let's talk about what is happening up on the International Space Station. The International Space Station is the first and only orbiting laboratory. Hi, Ferg. Good to see you. Thanks for commenting. Thanks for stopping by. We need to talk, you and I, by the way. I just thought I'd share that with the whole world. But anyway, so the International Space Station is in low Earth orbit. So that makes it a special kind of laboratory, but what does that mean? Well, let's see. Let me grab my Earth here. And let's talk about what it means to be in orbit. All right. You may have heard of the term freefall. That's used in a variety of ways. People who enjoy skydiving will experience free fall. Free fall is basically when you have gone as fast as you're going to go before you hit the ground. There is what's called a terminal velocity. So everything that falls because of gravity is going to get faster and faster as it gets towards whatever it's being attracted to, up to a certain point, and then it just continues at that same speed. That's terminal velocity, and that's when you feel weightless, because our bodies actually do not feel motion. We only feel acceleration, and I use that term acceleration to mean any change in speed or direction. Okay, so that could be slowing down, speeding up, suddenly going down. Those changes in our motion, that's what we feel. So when you are falling, Ferg has given us all the statistics. Excellent. When you are falling out of a plane, before you hit your parachute, and Ferg, by the way, just give me a thumbs up or something. Let me know if my sound is okay. This is the first time I've used this setup. You'll reach that point where you're no longer speeding up, and that's when it feels like you're just floating. I've never done that. I can imagine, thank you for the thumbs up. I can imagine what that would feel like from my diving experience, but yeah, you hit that terminal velocity, you're no longer experiencing acceleration, and you're in midair, so it feels like you're floating. All right, so let's apply that to the Earth. When you throw something up, it's going to come back down. If you throw something up and away from you, it's going to go away from you and come back down. The more acceleration you can get going sideways. I see that, Ferg. I bet. The more acceleration you can get going sideways, the further the object that you're throwing is going to travel away from you before it falls to the ground, right? We know this conceptually. Well, if we think about it on a planetary scale, if you go up and you've got acceleration and it lands here. Well, if we go up higher and have more acceleration, it lands here. If we go up and we have more acceleration, it lands here. If we can get enough, let's see where I'm not blocking myself. If we can get enough sideways acceleration, so wait, I need to do it this way, so that we go up, and then we miss, like when we're about to land on the Earth, we miss because the Earth curves away and we're going fast enough. That's what puts us in orbit. So an orbit is actually a continuous fall. We're just falling and always missing. Each time, we're just missing our landing because the Earth is curving away from us. Parabolic trajectory. Ferg, man, you're after my job. So that creates a free fall environment, or a low gravity, microgravity environment, or a weightless environment. All those things refer to that feeling that you're at terminal velocity. And that's the environment that exists on the space station. So that opens up some questions, because all of the science that we do up until this point anyway, most of it is impacted by the Earth's gravity. We can't do anything about that. But what if we could? What if we could take that whatever effect that is that we don't even understand, and remove it from the equation and see what happens? That may help us understand the answers to some questions we didn't even know we had. Hi, Becky. Thanks for dropping in. It's good to see you. So that's why science on the space station is exciting, because it is in that low Earth orbit. It's only about 200 to 250 miles up. It's not really that far up. But it's in free fall. So we can do science experiments and take gravity out of the equation and see what happens. Okay, NASA does a good job of sharing this stuff if you know where to follow. So if you follow NASA on YouTube, then look out for their Spacecast. This gives you kind of a... They take all of the different episodes that they have for each thing about science and put them all together. So there's space station stuff in here, as what the Parker Solar Probe is in here. What is this, Ferg? In The Hitchhiker's Guide to the Galaxy, Douglas Adams described falling as falling over and missing the ground. Yeah, exactly. Flying. Yes, exactly. Exactly. I remember that. You have to fall over and forget that you're gonna... I think I tried that once when I was younger and had forgot to forget. Okay, so I want to show you what are some current science experiments going on at the space station. So let's move up here. Okay, this is flight engineer. Let me make sure I get her name. This is flight engineer Serena Onan Chandler, and she is in the Destiny lab module. That is one of the U.S. components. And she is working with scientists on the ground on an exciting potential cancer treatment. So I'm just going to let her tell you what she's doing, and then I'll make some comments after, if I can, hold on.
To test new cancer drugs to prevent that blood supply from growing. And if we can...
Hold on. Sorry, I missed her introduction, sorry. All right, so she's looking at these cells. They're called endothelial cells, and they control the blood supply.
So why is this important? Well, endothelial cells help form blood supply, and tumors need blood supply to get bigger and bigger. And all of us have had someone impacted by cancer, whether it's a family member or a friend. And so we're always thinking, how can we fight this cancer? Well, one thing we're looking at is, can we grow these cells on orbit to test new cancer drugs to prevent that blood supply from growing? And if we can stop that tumor blood supply from growing, then we can help beat that cancer. So that's just one of the science experiments we're looking at here on the space station. And so we're always thinking, how can we fight this cancer? Well,
I hope that was... that might have been too soft. Hold on, I got it.
Supply from growing.
Thank you for your patience. Again, I'm working in a brand new setup, so I can't get what I want on screen at the same time. Oh, here we go. I'm back. Hi. Did you miss me? Okay. So I don't know if you could hear that or not, but just to summarize in case you can't, the cool thing that she's doing here is she is growing these endothelial cells that your body uses to control the blood supply, to see if they can use that to cut off the blood supply to tumors, to cancer tumors. And when they grow them here on Earth, they can't get them to live very long. So they're looking to see if something different happens in space. Now, I'm going to move this ahead because I want you to watch just the logistics of doing a science experiment in free fall, in low Earth orbit. Notice that she's got the Velcro strips here, but you must have to be so methodical because stuff will just go flying away. So let's continue watching this.
Where all the cells live in their biocell habitat. And when we're done working with them, We put them in something called Sable 2, which is up in the ceiling for ISS, and it feels all nice and warm and comfortable, because it is, because it's just like the temperature of the human body. And so we let the cells live and grow there, and we've had them for almost 2 months now up here on ISS. We feed them, we give them nutrients, and they basically live. They're like miniature crew members living with us. So we're going to this new biocell, which is Delta 7. And these biocells here have been treated with varying levels of a cancer chemotherapy drug that is being tested out here on ISS. And so we are looking at the cells. The researchers look at the images that I take for them on the microscope to see how well that drug is impacting the connection between those endothelial cells, to see if it will stop this tumor blood supply from growing. Make sure that's level.
Main position to forest and face slider at the leftmost position for the first image.
And you can see some of these tubule formations here also.
Good spot.
Yeah, I agree, it's a good spot. You do see definitely some of the tubule.
So that's exciting work that she's doing there. I gotta make sure that I'm not muted. Okay, good. Let's zoom in on this, because look at that. Growing those cells. So that's one of the many science experiments that's going on right now, is to see if we can find a better treatment for cancer. Oops, sorry. Hold on. I'm experiencing some technical difficulties. There we go. Okay. By the way, if you want me to feature your location where you are viewing from on the Skywatch alert or the Skywatch news at the beginning of the show, then let me know when you join. Let me know where you're from, and then I'll set that location, and we can switch it back and forth. Okay, so sorry, that got away. The technology got away from me, and I am just resetting myself, and I'm back. Studying cancer treatments on the space station, seeing if the absence of the effect of gravity has an impact on the cancer treatments. So that will be exciting. As well as medical science, there is science done on the space station using its unique position in orbit above the planet to make observations of the planet and compare them over time. So for the past 40 some years, NASA has been keeping regular measurements of the output of radiation from the sun. And we just launched the NASA's Parker Solar Probe, and if you missed that, go back, check out the older episodes. I did an episode on that launch. But the space station is also instrumental in measuring how much energy is coming from the sun and how much energy is being reflected back into space, how much is being retained by the atmosphere, and how much is making it all the way down to the ground. So we have different layers of the atmosphere will reflect or absorb or allow the pass-through of different types of radiation. So, as it strikes the atmosphere, all the radiation from the sun, some of it is absorbed, some of it is reflected, some of it makes it all the way down to the Earth. And they've been keeping track of the temperatures. This instrument here is called the Total and Spectral Solar Array Sensor. And it has two main instruments. Move myself out from behind. Hi. Two main instruments. One of them measures the amount of radiation coming from the sun, and the other the other measures the type of radiation coming from the sun. It's important to know this when we are analyzing data about the state of our climate. So, because we know, regardless on whether or not you believe that people are contributing to it, the planet is getting warmer. That's just the measurement. Okay, can't, unless you think all the thermometers in the world are rigged. The world's getting warmer, and it's in our best interest to figure out why. Maybe we can't do anything about it, but it's worth a shot, right? Okay, so understanding the type of radiation that's coming to us from the sun is very instrumental in that, because the different types of radiation are reflected and absorbed at different parts of the atmosphere. So, for example, this illustration is showing ozone radiation heating up the atmosphere, and some of that heat radiates down through the atmosphere and starts to affect the temperatures in the upper atmosphere, which that's the whole engine that drives the climate on Earth. Okay, I encourage you to check out science at nasa.gov. They do a really good job of sharing the science that they are doing, not just on the space station, but remember that NASA is the National Aeronautics and Space Administration. So they are doing a lot of science with aeronautics as well, using airplanes to observe the Earth, using airplanes to observe space, making better, more efficient, softer as in quieter airplanes, more fuel efficient. So keep all that in mind. The NASA is a lot more than just the space station. All right, that was what I had on the list to cover. Unless you guys have any questions, pop them up in the comments. I'm going to give one last look at the night sky in case you tuned in after that, so we can see that. This is looking at the sky from Houston, and notice the array of planets going from horizon to horizon, pretty much. And that bright star there, Antares, is in the constellation Scorpius. Remember, I want you to try to learn some constellations. So see if you can find that tonight. It's between Jupiter and Saturn. So Jupiter should be pretty easy to spot. Saturn will look kind of yellowish, a lot paler, and to the upper left if you're facing south. Okay. Thank you so much for joining me. I hope you had an amazing weekend. I hope you have an amazing week. And until I see you again, don't forget to look up. Bye.